Hello, I'm Li Dechen, a waste management engineer with the University of Idaho. Idaho has a strong dairy industry, ranks among the top 5 milk production states in the nation. As a byproduct milk production, huge amounts of liquid manure are generated each year in Idaho. Solids and nutrients in the liquid manure pose several challenges to manure handling processes. Most of our dairies are familiar with the benefit of solid-liquid separation. A few have incorporated a secondary solid-liquid separation technology on their dairies. The objective of this video is to showcase the use of centrifuge as a secondary solid-liquid separation technology on 2 Idaho dairies. Prior to visiting dairy sites, let's hear Rick Nearbout's perspective on solid-liquid separation. Rick is the Chief Executive Officer for the Idaho Dairymen's Association.
All right. So Rick Nearbout, CEO with Idaho Dairymen's Association, and today we're talking about manure separation and why we encourage dairymen when they can to increase the separation efficiency on their dairy operations. And there's a number of reasons to do this. And there's some very unique technologies like centrifuges that are out there starting to be employed by dairy producers here in the state of Idaho. You get a number of benefits from increasing separation out of your liquid manure and that liquid manure storage area. First, you have to clean out that liquid storage area less often. If you have too many solids in your lagoon water, it's going to settle out and you lose storage capacity, as well as have a lot of sludge and slurry at the bottom of your ponds, and that requires cleaning periodically. So if you can limit the number of times you have to clean your lagoon, there's a direct financial savings there, and you don't also possibly disturb the integrity of that lagoon liner. So from a management standpoint, you know, that's one of the early benefits. Some of the other benefits that aren't as widely recognized, one would be as you take solids out of liquid manure, you also reduce the emissions coming off of that lagoon. So if you're looking to reduce your environmental impact on air quality issues, pulling those solids out are gonna reduce that emission factor coming off of that lagoon storage area. So there's a benefit to air quality that can be recognized. And then the last area would be the ability to move nutrients further away from the dairy operation itself. If you're pulling the solids out, you can put them in a more transportable form. Typically the phosphorus and nitrogen are largely going to stay with those solid particles. And so as you pull solids out, you also pull those nutrients out, and you can move them further away from the dairy operation and not end up with concentrations of high phosphorus or nitrogen in the fields that are surrounding the dairies. So a number of reasons to look at improving solid separation and a number of ways to do it. We just really encourage dairymen to incrementally increase their solid separation. If they're, you know, they don't have the capital to go all the way with a very advanced system, do what you can to just incrementally improve that separation on your facility, and it'll have benefits for the future for you.
Hi, my name is Dean Swager, and I own the farm here. And we have been here in Idaho since the year 2000. Prior to that, we dairied down in Southern California in the Chino Corona area. This farm was started by my father in 1945. A small number of cows, and it's grown into what we see today. Today we milk about 4,800 cows, and we have 2 facilities, approximately 1,000 acres in total, which we farm also, grow some of the feed for the cows. And in a nutshell, when a lane is flushed, it goes down to the first receiving pit. The first receiving pit pumps over some core screens, which gets the initial solids out. It then flows from those screens down to a bottom removal pit, which we call it, which is shaped like a V at the bottom with a pipe, and that pump turns on again based on fill to pump off the bottom solids that have settled to the bottom off to another pit that in turn feeds the centrifuge. The centrifuge runs at about 250 gallons a minute, which polishes the water, takes out the solids that the coarse screens have missed. And also the reason we have coarse screens is to take out the initial solids and any debris that might damage the centrifuge. After the centrifuge, it's back in the system once again to be reused for flushing. I don't know exactly, but I would say probably in the 7,000 to 10,000 gallons, based on how many minutes the flush pump runs for each particular lane. There's I believe it's like a 12-inch pipe from that flush pump up to the top of the dairy that feeds the valves that are up top. Give or take 7 to 10, I would say. Minutes of run time. You know, the lanes that the cows eat in versus the back lane in the back of the beds, there's a 2-minute differential there because most of your waste is going to be where they eat. Clean water comes this way and the dirty solids go that way. Yeah. It comes in through that pipe there, and that particular pipe runs all the way down here with different places that it injects. This is the control panel for the centrifuge. Right. I can tell you when it's running. We run at about 1,600 RPM. There is, I think it's a 125 horsepower motor to turn the barrel on the outside. And there is, I think, a 50 horsepower motor that turns the auger on the inside of that barrel. Each one of those is within a paper tolerance of each other as they're turning. Now the auger on the inside is regenerative because it's always trying to hold back. If the main barrel is running at 1,600 RPM, the auger, and it's all controlled by the PLC, the auger might run at 1,590 RPM. So it's always holding back. So actually that horsepower is regenerative. So if the main drive is pulling like 85 amps, the back drive is pulling like 35 amps, and it's actually taking away the amps that are on the larger motor, so it doesn't take as much power as one might think. Now the operation of the centrifuge, the auger on the inside, when solids are spun, they're spun and they stick to the outside just like your wash machine does with your clothes. That auger, turning a little bit slower, pulls them solids at a constant rate and brings them up an incline inside the centrifuge, and it gets drier as it goes. So when it finally ends up dropping out of the centrifuge through nozzles on the end, it's dry enough to make a coned pile off the end of the centrifuge. Eight from the primary screens and 4 probably from the centrifuge every day. I would say prior to the centrifuge, we were probably only getting between 5 and 6 loads total per day. And once we put the centrifuge in, the primary screens worked so much better, and also we were removing all the fine fines that were always so hard to get. Once a week we pressure wash our screens and acid treat them whenever necessary. The centrifuge goes down once a week and we grease it because there's bearings on the inside of it, and there's a proper method of maintaining the centrifuge. Basically, the centrifuge doesn't require a lot of maintenance other than once a week. Grease, mainly. I don't need to clean my lagoons hardly ever. They have been, you know, before it was a full-time job to stay ahead of lagoons. Every year I was cleaning at least one lagoon. And now that's not necessary with the centrifuge. With the centrifuge, you can see the tire tracks at the bottom of the lagoon that you cleaned from the year before, the next year. Absolutely. I think every dairy farm could utilize the centrifuge in some way or another.
We're at Bettencourt Dairy number 1 of our 9 facilities that we have. Currently we're milking just under 13,000 cows and irrigating about 1,000 cows off of, or 1,000 acres off of our lagoon. We started this facility in 1999, so it's 20 years old right now. We remodeled about 3.5 years ago from an open lot to a cross-fed facility, and at that time is when we updated our manure system. At Dairy 1, the process flows from the cross vent being vacuumed, from the vacuum dumped into a pit where it is mixed with barn water. From that point, it gets sent over a sand lane to try to desand as much as we can. From there, it is dumped into another reception pit. From that pit, it is pumped over 2 sets of slope screens. The 2 slope screens then pump it out into the next pit. And from that pit, 2 more pumps pump it back over 2 centrifuges. Both centrifuges and slope screens are parallel with each other. From that point, it leaves the centrifuge and dumps into another pit. And from that point, it is pumped up to the lagoon. We are processing approximately 700,000 gallons of water manure a day through the slope screens and centrifuges. The sand lane is cleaned twice a day. In all reality, it could probably be cleaned 6-7 times a day. It's just it's labor intensive, and you have to hit it when the sand or the flush lane isn't running, so it's a timing issue. Yes, no water is brought back onto the dairy. It all goes to the lagoon and then through a pivot system pumped onto our fields. Approximately 22 ton a day from the slope screens of fiber. 20 to 25% of that, 100% of it is composted, and then 25% of that is used for bedding, and then the remainder is shipped off-site, sold or used on some of our other fields. From the centrifuge, the cake, we are approximately 24 ton a day. The reason there's so much weight there is just the sand dropping out and hauling that off. The screens have an auto washing system that runs approximately 6 times a day. That is really how we keep the screens running at the pace that they're running. If we didn't have the auto wash, I'd have to have a guy come in 6-8 times a day and manually shut it down and clean it. If it were to fail, you got about 12 hours to get it going again, else you'll be out there cleaning it. From there, it's cleaned weekly through the screw presses and everything underneath, just maintenance, cleaning up any residual manure that's fallen over. But once a week, roughly, we tear it down and put it back together. The centrifuge, once a week, we have a company come out and shut down each centrifuge, clean it. There's a flush system that goes through it. From there, they check in the oils. It's got a air pressurized drip system to lubricate the bearings. And then once the plan was, or the budget was, once a year to do a bowl exchange where we will come out and they'll pull it out and put a brand new rebuilt from the factory in. Right now we went 15 months, so we're doing better than we realized. When we added the second screen, we think we'll do even better. We're not going to be hammering those centrifuges as hard. Basically, a centrifuge, you know, at the RPMs it's spinning and at the volume of water getting pushed into it, it's sanding it down. The first maintenance, we found that the inside of the centrifuge was relatively in good shape, a lot better than what we had planned. But the very end of the centrifuge where the water is hitting, it looked like somebody just sandblasted the wall in, dented it in, just wore it out. You know, if we could control that, that would add more time onto the life of that centrifuge. So the second centrifuge was added after our goal was to capture all of the water. And with one centrifuge, we were able to screen all the water, but we were not able to run the water through the centrifuge completely. By adding the second one, we were able to slow down the amount of water coming in, speed up the centrifuge, and our capture rate increased, not only from the extra 150,000 gallons that we're capturing, but by slowing it down, we were able to keep that water in the centrifuge longer, spinning more of the particles out. We're guessing that increased it by about 2 million pounds more a year, just by slowing it down, not by adding the extra centrifuge, just by slowing it down and capturing more particles that were going out to the lagoon. Yeah, the hopes were we can go from, you know, conventional open lot once a year cleaning the lagoons with the slope screens and then the centrifuge added on. You know, that's what, 440,000 pounds of manure that you're, you know, trying to not have to pull out of that lagoon. Fuel, labor, a lot of other issues come onto there. So going to every 3 years will easily pay for the second centrifuge. The main goal, obviously, is our field. You know, to get rid of the manure. You know, we want our fields to produce better. If we don't process it, our fields will suffer. That's number one. Cleaning, money savings, labor, it all ties together. The other goal is just, you know, the standards are going to get tougher. We already have, you know, ammonia management systems and everything, and in time I see it getting tighter and tighter. And you know, we want to be good stewards, so we want to do the right thing. I feel this is the definitely beyond the first step of that direction, but it's a big step for us, and I feel we're doing the right thing and going the right direction. The two centrifuges I've said this before, we weren't promised anything that we didn't get. We were told it's going to be X amount of dollars a month to run, and about once a year, plan on a little over 100,000 to repair. We're at 15 months, and we're actually only like at 80,000. So they told us it would take about 50% of what you're going to put into it come out of it. Obviously, if you get too thick, it really skews it, and there's a certain point when you're running almost water, you're not going to get that. But on the average, 3%, anywhere we put into that from 1.8 to 3.8% solids going into it, and that equates about half every time. If I were to do it again, where this is not a flush dairy and it's a vac dairy, I would not mix the water with the manure coming off the vac truck. Basically, you're taking good 13% manure and diluting it down so that you can run it over a screen, so that you can thicken it back up and pile it, so that you can centrifuge it. I think I would have went straight from the vac to a screw press system, and then to the centrifuge. Would have used less of the clean water. We'd only process, I believe, it was going to be 250,000 gallons a day through the screw press and centrifuge. The rest, we could choose to run it through the centrifuge, but the water's pretty clean. We just maybe run it over a slope screen and send it to the lagoon. Number one for me would be, we've got the solids figured out. We know that just processing to whatever extent you're going to get there, whether you're using polymers in the centrifuge or just conventional, you got that. It's the dissolved solids. You know, if we could find a way to get those dissolved solids captured through, you know, a feasible technology that's, you know, affordable, that would be, to me, the biggest reward for all this, or game changer, if you want to use that word.
We hope you learned something from this video that advances your knowledge and helps you make better decisions about upgrading your solid and liquid separation technologies. Please contact us if you have any question, comments, suggestion. Thank you for watching.